There are two set of data is given. So now first set of data we are assuming N1, second set of data we are assuming N2. In case of left tile, what we are doing here 10, 20, 30. So here see we are marking in the X series here 10, next to 20, 30, like this which is going, that's what the value based only we are able to plot the graph. Which number is repeated 2 or more times, that one it can be considered as a mode. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. So we are in the Unit 2, Section 5, third semester BCom, measures of variation and skewness. So in the last session which is related to the measure of variations, now this session which is related to the measure of variation as well as skewness. So the few topic which is related to the property of standard deviation and the property of variance which is related to the measure of variance. Okay, now moving forward, my today agenda is the property of standard deviation, okay, and the property of coefficient of variance and relative skewness using Pearson coefficient of skewness and Bowley coefficient of skewness. Moving forward, so here the property, of course, any arithmetic mean or central tendency or measure of dispersion, if you try to study, the property is playing very important role here. So in the standard deviation, what kind of property we are able to identify? If all the observation assumed by variable or constant are equal, for example, the X series is given like 4, 4, 4, 4, 4. Okay, now you need to get the standard deviation which is completely based on the arithmetic mean. So when you are taking the total sigma x, we are getting 16. Okay, now if you are with the help of 16, when you are trying to find out 16 divided by 4 numbers, right? So you are getting 4. Okay, now when you are trying to go for the arithmetic usage standard deviation, the root is nothing but here see sigma, the sigma whatever it is there, x minus x bar divided by small letter n. So if you simplify, so here the x bar we are getting 4. So here if you try to, according to formula whatever it is there, if you are trying to extend one more column like here, so 4 minus mean how much you are getting, we are getting 4. So 4 minus 4, 0. That's what here, if all the observation assumed by the variable are constant, that is nothing but equal, then the standard deviation is 0. How we are getting 0? That is only. Okay, now if you simplify, see finally we are getting sigma total, here also 0. Anything 0 divided by 0, 0 only we are getting. That's what, which is very transparent to understand here. This means that if all the value taken by variable x is k, say, then standard deviation, this is also, this symbol also we can use for standard deviation. Okay, 0. This result applying range as well as mean deviation. In the mean deviation also, when we are trying to get the standard deviation based on the arithmetic mean, so there also we are getting 0 only. So based on the mean deviations only, the standard deviation formula is completely designed. Okay, next is the property, the standard deviation remain unaffected due to change of origin. Due to change of origin, now it is origin. Okay, so but it is affected in the same ratio due to change of scale. If the scale is changed, obviously the standard deviation which is based on the origin or scale, if it is scale change, even the result also, the standard deviation value also change. That is, if there are two variable x and y related. Now in the last session I have explained the few problem which is related to standard deviation. So x series and y series using just for comparisons. Okay, in that case. Okay, here there is one small equation is there, y is equal to a plus bx for any two constant, a is one constant and b is one constant. Okay, then the standard deviation of y is given by, like this it is given. See, when here the bx value, this is your scale. So when the scale is changed, obviously, which is not affecting for the your constant value. So here a and b is completely is there. There is one equation is transparently it is there, so that the standard deviation of y is given by standard deviation of y. This symbol you have to read like this, mode. So mode of x, standard deviation of x. Moving forward, there is one more property which is related to standard deviation. If there are two group containing n1 and n2, So there are two set of data is given. So now first set of data we are assuming N1, second set of data we are assuming N2. Observation. So obviously when the two set of data is there means there are two mean is given. Okay. So using this information N1 and N2 x bar 1, x bar 2 as respect to arithmetic mean. Now here the standard deviation, now we need to, because everything is coming two items. Okay. So even the standard deviation also set 1 standard deviation, set 2 standard deviation. So using the respective standard deviation, now we are able to find out the combined standard deviation. Okay, using this formula. Standard deviation, combined standard deviation is denoted C. Now square root inside, because there are two set of data is given. The standard deviation, the first set number N1 into, when you are writing this one is your standard deviation, when you are taking a square which is nothing but variance here. Okay, now whatever the standard deviation is value is given, for example the standard deviation 10 is given means, now if in case of here what you are writing 100. That's it. Okay, now so the same thing, N1 into variation plus D1 square. How we are getting D1 square value? So x bar mean 1 minus combined mean. So according to formula, combined mean formula, N1 into x bar 1 plus N2 into x bar 2 divided by N1 plus N2. So this is your combined deviation formula. According to formula, whatever it is there, which is clearly you are getting more clarity. So this is first class and second class. Okay, same thing. We are writing N2 into variation 2 plus deviation 2. So the deviation 2 also same thing, because whenever you are trying to do for the combined standard deviation formula, all the informations of course they are providing. Okay, moving forward. Now, so the properties of a variance or coefficient of variance. Okay, some of the property of variance are given. The variance always you have to write like this, the symbolically, which is representing a standard deviation when you are taking a square, which is a variance. Okay, the some of the property of the variance are given below that can help to solve both simple and complicated problems sum. Okay, variance related problem if they are asking. So using that property basis only we are trying to solve the problem. If the value of the variance is 0, if the value of the variance is 0, it indicates that all the data point in the data set are equal value, because as the data set basis only any problem we are able to solve. So the data set X series or Y series, whatever it is given, if the variance is you are getting 0, the final equally value. Okay, so next property, a large variance implies that the data is more vastly spread out from the mean, because when we are trying to compare which cricketers is better, okay, more consistent, so using the coefficient of variance only we are able to rank, right? So that's what. So the variance is very important to when you are studying, which is based on the mean and standard deviation. Variance formula I am writing one more time. Okay, standard deviation divided by x bar into 100. Okay, now based on the standard deviation, if you want to solve based on the average only we are, because the formula is having completely average basis. Similarly, the small variance show that the value of the data point is closer, greater and clustered around the mean, because the value what we are getting, so based on the conclusion when we are writing comment we are writing, so completely the variance basis only, who is more consistent, who is less variance. Okay, moving forward. Now there are few properties here. Variance of x plus c is equal to variance of x, which is symbolically we are writing, where x is a random variable and c is a constant. Okay, next property. So variance of ax plus b is equal to a square. Here a and b are constant. Okay, next one, variance of cx is equal to c square. Okay, here see, when you are writing ax, a square it is, here cx, c square coming. So variance of x, C is a constant. Now last property, variance x1, number 1, the set of data, for example 10, 20, 30. Now this one is your x1, x2, okay, x3 till xn. Okay, now how many numbers they are giving based on that? x1 plus x2 plus till xn. Okay, so the is equal to variance x1 plus variance x2. So till then x, okay, you have to extend the line where you have to take the summation. So where x1, x2, xn are independent random variable. Next, moving forward for the next topic, so the skewness. Okay, so in the second chapter, skewness, how the skewness is means what? The data set, whatever it is given, how data set is spread. So describe the degree to which the data were deviate from the symmetry. Symmetry means what? How the distribution which will be equally dividing. For example, this is your curve. Okay, now so if you try to take the center point 0, so which is always x bar is equal to median is equal to mode. So that is symmetric. Symmetric means the peak of the curve, the peak of the bell-shaped curve, so which is nothing but symmetric. So when the distribution of the data is not symmetrical, it is said to be asymmetric, because if you take in this case, so if it is the graph is going only one side, so then it is not equally distributing. That's what we are able to identify, which is related to symmetrical or skewed. Okay, so next, the measure of central tendency and variance do not relieve all the characters of given data set. In the measure of central tendency, we are not able to focus what is the distribution, the degree of variance we are not able to identify. For example, the two distribution may have the same mean and same standard deviation, but may differ widely in the shape of their distribution. When we are trying to draw the curve like a bell-shaped curve, so the distribution, when mean also it's equal and standard deviation also same. But in case of a bell-shaped curve, we are able to identify the difference here. Okay, either the distribution of data is symmetrical or it is not. Okay, either it is equally dividing, okay, either it is going for the down, okay, one side, left side or right side. If the distribution of the data is not symmetrical, it is called asymmetrical, because when it is the curve, when the bell-shaped curve is equally divided left side and right side means, so this is your left tile, and this one is your right tile. So compared to left and right tile, which is equally distributed, for example, here also 0.5 we are getting, here also we are getting 0.5, now which is looking like a symmetric. So in case of here, the bell-shaped curve which is going for the left side, so which is asymmetric. Okay, so thus skewness refers to the lack of symmetry in the distribution. That's what we need to study. With the help of skewness only we are able to identify. Now the graph is moving forward. A simple method of detecting the detection of the skewness is to consider the tile. I told you, left tile and right tile. So when the curve is going leftwards, so left tile, right side means right side the curve is going. Okay, the distribution. Data are symmetrical when there is no extreme value in a particular direction. Okay, no extreme value. For example, the graph, it is showing like this. When it is going left down, which is not equally distributed, now it is positive sign. Okay, because which is going right side. If it is, the graph is going for left directions, so this is your negative. Okay, so based on the graph only, the data set only, we are able to plot the data. So the low and high value balance each other. In this case, the mean, median, mode is equal to equal, because that is a symmetric or skewed. If the longer tile is towards the lower value left hand side, okay, the skewness is a negative. Okay, so when the graph is going like this, which is negative, okay, so negative skew arises when the mean is decrease in the some extreme low value, because the low value, for example, here given the data is given, for example, 20, then 10, okay. Now here like this, when it is going, which is going for positive. In case of left tile, what we are doing here, 10, 20, 30. So here see, we are marking in the X series, here 10, next to 20, 30, like this, which is going. That's what the value based only we are able to plot the graph. Thus the mean, making the mean is less than median, median is less than mode. So in this case, okay. So if the longer tile of the distribution towards the higher value, the right hand side, the skewness is positive. Now reverse, 30, 20, 10, okay. Here this is your graph. When you are marking the first value, it is here, second value here, now third value 30. So like this the graph is going, so right side. So the positive skew occur when the mean is increased the some unusual high value, therefore making mean greater than median, median greater than mode. Okay, moving forward. So here there are two types of, we are able to identify under types of distribution relative to mean, median, mode. We are based on the central tendency, we are able to give a relationship here. So symmetrical or normal distribution. Now this graph is equally divided left side and right side. So we can call it as, which is a symmetrical, okay, equal symmetrical. We can't say it is an asymmetrical, because left side is equal to right side. Here also exactly we are getting 0.5. Here also we are getting exactly 0.5. Okay, the total graph is which is looking like a bell-shaped distribution. Okay, it is very useful for the probability problems. Okay, at the time of doing a problem, they are asking to plot the data with the help of bell-shaped curve. So bell-shaped distribution, the mean, median, mode, because the relations based only we are trying to plot the data. So all the located one point only, because exactly mean also locating here, median also locating, mode also locating. Okay, moving forward. So here next one is a positive skew distribution. Positive skew distribution which is going from the right side to left side. Okay, the observation is mostly concentrated towards the smaller value. At the time of plotting, the smaller value to which is increasing order. So smaller value, there is some extreme high value. The value when you're plotting, you have to go for the X series and Y series, seeing the frequency as well as X series class interval. So like this, when you are extending the graph for the right side, so which is going for positive, also called skewed to the right distribution. Okay, so here mode, median, mean. Okay, here so mean is less than median, median is less than mode. So in this case it is a positive. Okay, moving forward for negative skew distribution means the observations are mostly concentrated towards the larger value, then and there's some extreme low value, well now which is starting from the low value, so still it is extending. Now the curve is going for the left side, so that's what which is a negative skew. Okay, so also skew towards the left distribution. In this case mean is less than median, median less than mode. Okay, moving forward. Now here under relative skewness, you can expect 100% expected one question from the relative skewness using Pearson coefficient of skewness. So the Pearson is a person. Okay, so he introduced the concept like coefficient of skewness in order to make comparisons between the skewness of two or more distribution, the set of data, when you are trying to compare with the two set of data, so of course the distributions we are able to select here, the coefficient of skewness given by the Pearson can define the formula. So here the skewness we are writing, when we are trying to solve the problem, we are using Pearson. The S stand for skewness, K stand for Pearson skewness. Okay, here the mean, in the symbolically we are writing mean, and minus mode. In case in the problem we are able to find out the mode, so which is directly, then divided by standard deviation. Very simple. Once again I am repeating, skewness of Pearson skewness is equal to x bar minus z divided by standard deviation. In the problem, the data set, if you are able to identify if it is a data set, discrete group or ungrouped data or continuous data. In continuous data, no doubt we are able to identify the mode. Okay, so in case of discrete group ungrouped data, the number is not repeated in that sequence, the question whatever it is given, which number is repeated 2 or more times, that one it can be considered as a mode. If you are not able to identify the mode, better you are going for the alternative formula. One more formula is here. The same Pearson coefficient of skewness is equal to 3 into mean minus median divided by standard deviation. This formula, in case of mode is not given, now we are able to depend on this formula. Okay, if it is mode is given, we need to depend on this formula. Okay, so if the value of this coefficient is 0, the distribution is symmetric. The 0 means exactly here 0. Okay, symmetric, because equal side distributing equally. Okay, so if the value of the coefficient is positive, it is positive skew. Positive skew means here which is going for the like this. Okay, and distribution, if the value of the coefficient of negative, which is going for the left side. Okay, which is going for left side. So it is a negative skew distribution. In practice, the value of this coefficient usually lies between plus or minus 1. Okay, moving forward. So next one is a Bowley, a relative coefficient of skewness using a Bowley. Bowley coefficient of skewness, how we are able to, so which is the last Pearson, which is completely based on the measure of central tendency and deviation. Okay, so here see arithmetic mean formula, if you try to write here sigma x divided by n. Okay, if you are writing a standard deviation formula, here sigma x square divided by n minus sigma x divided by n to the power of square, because which is related to the mean. So that's what the standard deviation is completely based on the mean related formula basis only. Okay, in case of Bowley coefficient, we are always depending on quartiles. Okay, quartile basis, quartile 1 and quartile 2 and quartile 3 only we are able to find out the formula whatever it is given below. Here when we are given open-ended distribution, okay, where extreme value are present in the data or position measures such as median or quartile. So here see the quartile 2, which is nothing but your median, right? So that's what based on the formula whatever it is required. So completely Bowley coefficient of skewness, which is depending on the quartile basis or median basis. Okay, so nothing here. So the formula for coefficient of skewness given below is more appropriate. Very symbolically we are writing skewness means S. Now Bowley means K. Clear? So here Bowley means K. Q3 plus Q1 minus 2 median you are writing divided by Q3 minus Q1. Clear? So this is your formula for finding the Bowley, which is completely depending on the quartile basis or median basis. So according to formula, whatever it is required, either now you need to decide which type of data set is provided, either discrete ungrouped data, what is the procedure, what and all steps we followed in the when we are trying to solve the problem related to the quartile. So the same procedures you need to follow here. So again, if the value of this coefficient is 0, it is a symmetrical distribution. Same thing, 0. For positive value, positive skew distribution. If negative value is given, negative skew distribution. It's very important to identify, because at the end of the problem, we are writing a conclusions or a comment we are writing. Keep on watch for next section. Thank you.